Hello, Year 7. Welcome to this lesson on symmetry and reflection. We're going to be needing some square or graph paper. So if you don't have any and you've got access to a printer, then in the description for this video, you should find links to versions of the paper that you can download. Okay, with that said, let's get started. So first thing, we need to copy down these shapes and draw on all the lines of symmetry that you can find. You can see they've done part A for you. Remember, symmetry lines are where you could put a mirror and it would reflect correctly so that you'd get the same shape, okay? So hopefully you've paused and done part B. If you haven't, pause now, but the answer should be this, where there's only one line of symmetry and it's down the middle. If you put a horizontal line, either these curves would repeat down here and you'd get like a figure 8, or if you were reflecting this side, you'd get almost a diamond shape popping up here. Okay, so the only way where you'll get the correct shape by going down the middle is this way up. Okay, try part C if you haven't already. And you should have got this. Again, only the one line of symmetry. There are so many different shapes that there's only one way that is completely symmetrical, and it's down the middle here going horizontally. And for D, now there may be some answers you're not expecting here, so just make sure you have a look at it, twist your paper around and check all the places where it could fit. Okay, so these two should have been the answer. So a lot of you may have got this line down here, but also if you rotated that paper, you should be able to see that if you split down here, it would be the same on both sides. You get this curly E type shape, and you get the reverse of that on the other side. So there are two lines of symmetry there. The other type of symmetry we talk about is rotational symmetry. So that is when we rotate the shape, how many different times in a full turn will we get the same shape back, okay? So with this first one, for example, this rectangle, this is the first order of rotational symmetry. And then if you turn this upside down, it would also work. If you put it on its sides, it would not work. It would be facing a different way. But if you put this upside down, you'd get exactly the same shape. So that's two orders of rotational symmetry that rectangle has, okay? So try doing the same for B, C, and D, please. Okay, let's have a look at the answers. So we already said A had an order of rotational symmetry of 2. B is also 2. Again, if you flipped this, if you drew it, you could twist the paper and you would notice that upside down, this parallelogram would look exactly the same. The C with this sun type shape, you'll notice it's symmetrical whenever it's standing on one of these points. So we just had to count the number of triangles. The answer was 8. D, all of these sides are the same length. So when you rotate it round, if it's standing on a corner, then it will look the same. So there are 4 different ways this would work in rotational symmetry. So bearing those in mind, have a go at E, F, G, and H for me, please. Okay, and the answers should be as follows. So we've got a regular pentagon here, so that will work 5 times in a full turn. F here, all of these long edges will work, so there are 4 of those. G is an equilateral triangle, so if you lined up the 3 different corners to be in the same configuration, each time it would work, so there are 3. And H, this is a regular hexagon, so there will be 6 times where it looks the same. Now we'll have a look at some 3D shapes, okay? So with 2D shapes, they had a line of symmetry. With 3D shapes, we have what we call a plane of symmetry, because we have this whole section of 2 dimensions that will cut through. If we think of this almost like a saw, if we could saw into this shape at any point, will there be some reflectional symmetry, okay? So look at each of these shapes and work out, is there a place where we could cut this in half and we would end up with two halves that have symmetry. Okay, and you hopefully should have noticed that A, B, and D are all symmetrical, but C is not. Okay, hope you can see A have loads of different ways we could cut along here. In fact, each of these from the cuboid work for the cube, but also the diagonals work and things like that. For B, this Toblerone type shape, this triangular prism, we should be able to cut halfway down the length and we would get two equal halves. D, again, we could slice down the middle in various different ways and you can hopefully see we would get equal halves. Whereas C, unfortunately, that's not going to be, not going to have any reflectional symmetry. Okay, we'll look at some reflection now then. And what it's wanting you to do here is to say, firstly, whether or not it's a correct reflection in each of these examples. And then if it's not, it's asking you to do the correct reflection, okay? So it's the yellow shape being reflected. So if this green shape is correct, you just say, yes, it's a reflection. If the green shape is not correct, you say, no, it isn't a correct reflection, and then you reflect the yellow shape properly, okay? Pause the video, give it a go. Okay, so part A was a correct reflection. Part B wasn't, it's actually a rotation. So remember, if things are being reflected, we would expect these sharp edges to be touching each other, and it would look something like this. And for part C, again, it's not a reflection, it's actually a translation, so it's just been moved. But if it were a reflection, then this shallow edge would be, the thin part would be closer to the mirror line, whereas in fact, it's now further from the mirror line, okay? And remember, that's what we do everything in relation to is the mirror line. We want the things that are closer in our original to be closer in our image, and things that are further from the line in our original to be further away in our image. Question 7, it's now asking us to find the lines of reflection. And so remember, we've got our different lines, horizontal and vertical. When you have a horizontal line, it's the line y equals and the number it goes through. And when it's a vertical line, it's x equals and the number it goes through. I know we normally associate x with being horizontal and y being vertical, but if we think about what the graph is telling us, let's say we had a vertical line going through -2. Well, on this line, at any point, the x-coordinate is always -2. And that's why a vertical line is x equals and why a horizontal line is y equals. If we had a horizontal line going through +1, then that would be the line y equals 1 because the y-coordinate is always 1. Okay, so that's why they're the other way around. So it's probably worth writing down now, if you didn't know that already, some notes that x equals a number is a vertical line going through that number, and y equals a number is a horizontal line going through that number. Okay. So let's just check first that this part A is correct. So they've said it's going to be a reflection in the line x equals -1 from A to B. So let's look from A to B. Well, we can see the way it's been flipped, it's going to be a vertical line. So we're happy that it's going to be an x equals line. And let's look at the gap between these shapes. Let's look at two similar corners. Let's look at this corner here. And we can see we've got a 4 square gap between the two objects. If it's a 4 square gap from where we want to go halfway, which is a 2 square gap. And so we want this line, and as you can see, it's x equals -1, okay? So copy this diagram down and try and do part B for me, please. So it's A and D, these two shapes here, and we want the line of symmetry, please. Pause the video, give it a go. Okay, so hopefully you saw it was going to be a horizontal line, and we can see there's a 4 square gap again, so we need to go 2 squares between, and this is the line y equals 1. Okay, it's a horizontal line going through the point 1, so it's y equals 1. Now have a go at part C for me, please. Okay, so hopefully you've had a go. So we've got between D and E, we can see it's going to be a vertical line, and we can see there's going to be a 2 square gap. So we go 1 square in, and we can see that line is x equals -2. So same again, part D, please. Okay, let's have a look. We've got E and F. We can see it'll be a vertical mirror line, and we can see a 2 square gap. So we go 1 square. So we can see that's the line x equals +2. And finally, have a go at E, please. Okay, so C and F, hopefully we can see it's a horizontal mirror line, and the distance between them is 0. So half of 0 is 0. So we're going to use this line, which is y equals -1. Okay. And last thing we're going to do today is some reflections in diagonal lines. Now, we're used to reflecting in flat lines, horizontal and vertical lines, and we're happy with that because when they're flat lines, we just reverse the directions. So any up movements become down movements, and any left movements become right movements. We just reverse the direction. When it's in a diagonal line, it's a little bit trickier. There are different rules to follow. So let's look at those different rules. Okay, let's look at this part A that's been done for us. We can see, let's use this point as our center of attention. Okay, in our original shape, we would go up 1 for this line. Okay, we would go up by 1. But instead, if we look at this reflection, we've gone right by 1. And in fact, you'll find that's always the case with positive diagonal lines. So when y equals x, like it does here, up becomes right. And if we notice later on, where we've got a right turn here, we've got an upward movement here. So right becomes up. That's why I've got the 2-way arrow. Up becomes right and right becomes up. So you can probably see where we're going to go with this. But if we were at these corresponding points, in the original, we go left. In the image, we go down. So left and down interchange, okay? So when you've got positive diagonal lines, you'll go up instead of right, or right instead of up, and down instead of left, or left instead of down. When they are negative diagonal lines, however, it's slightly different. Up becomes left and down becomes right. Okay, so it's really worth copying this down. I know it takes a lot to get used to, and there may be other ways that you also work this out when you look at these images. You might find even easier ways for you to be able to do this. But these rules are always going to work, so it's worth copying these down before we give this question a go. And let's take this slowly, step at a time. So the first one we're going to do is part B. Okay, so hopefully by now you've copied all these down. You've copied all of the rules down and you've copied the diagram down. So let's choose a point on our triangle B. I'm going to choose this top corner here. You could have chosen any, but I'm choosing this top corner here. Now, the line is y equals -x, so it's a negative line. We're going to have to use these instructions here, okay? So whenever I'm talking about things, I'm talking about these instructions here. So let's go from that top point to this bottom point down here, okay? To do that, normally on my original, I would go down by 2. Well, using our rule, our image, that means we go right by 2. Okay. Once we've hit that point, we're now at these corresponding points. From here, we're going to travel to our third point in the triangle. We would normally go right by 2. We can see with our table here, we would instead go down by 2. Okay. And that is our final answer for B. Okay. Now let's have a look at C. At any point, if you want to give this a go by yourself, then please pause and you can either follow along or you can check your work as you go. So for C, I'm going to start by choosing this point that's touching the reflection line. Okay. And I always like to go straight along or straight up. I don't like to deal with diagonals until the very end. So what I'm going to do is I'm going to go left 2 to this corner. Now it's a positive diagonal line, so we're going to use these rules in the middle. Okay, so we've gone left by 2. We can see that's going to mean we go down by 2 in our reflection. Now we're going to travel to our next point up here. So normally we would go up by 2. Well, let's look at our rules. That means we're going to go right by 2. And now we've just got to join our 2 points together with our diagonal, and that is our answer for C. Now D, there are a lot of steps here. So I'm going to say straight off, we're on y equals negative x, so we're using these rules, okay? And see if you can follow along with us, even if you're doing one step at a time, just to check that you're following along exactly the same as we are. But try and do each of these mini steps yourself. So pause the video, give it a go, watch the video, pause, give it a go, etc. Okay? So we're using these rules for this shape. And I'm going to start by choosing this point. So if everyone starts by choosing this point, please, on their diagram. And I'm going to move to this point. Okay, so pause the video, use a pencil, see if you can work out using these rules how we're going to get from here to here. Okay, so hopefully you paused and gave that a go. So in the original, we go left by 1. So in our reflection, we can see we're going to go up by 1. Next thing I'm going to do is to choose this point. So give that a go, please. Okay, so to get from this point to this point, I would go down by 2. So in our reflection, we're going to go right by 2. Well done if you've been keeping up so far. If not, just following along. Make sure you write down all the instructions as we go if you're not sure. Now we're going to move along to this corner here. So hopefully you gave that a go. We go right by 1. So we must go down by 1. Now we move to this corner. So we went down by 1. So now we have to go right by 1. Now this corner. We went right by 1. So now we have to go down by 1. Almost there, 2 more corners left. If you want, if you feel like you're getting the hang of this, try and finish off the shape by yourself. If not, following along a point at a time. So we're now going to go to this point. So we went up by 2, so we've got to go left by 2. 1 corner left. We went left by 1, so we have to go up by 1. And finally, to get back to where we started, we would go up by 1, so we have to go left by 1. And that is our final reflection. Okay, so if you feel like you haven't quite got the hang of this, come back to this question another day and try and practice it again. See if you can come out with the correct answers. Okay, if you've got any questions you want me to answer, please email me and I will happily get back to you with that. Or email your maths teacher if you can't reach me and they can forward it on to me. Just say you need to ask Mr. Wright something. Otherwise, I will see you next week. Thank you very much.